Welcome to Simplify with Mr. Pi. Today we are doing lesson 5 of module 3. Today's question is, what is special about 1 and 0? So for the opening exercise for today, before I go over it, I want you to try to do these yourself. Pause the video, give yourself about 4 or 5 minutes, see if you can complete these, and then I'm going to go over them real quick. This is a review. Okay, opening exercise. Harrison checked the temperature outside to find that it was -12. Later in the afternoon, the temperature rose 12 degrees. Tells us to write an expression representing the temperature change. And what is the afternoon temperature? That's what we're looking for. So we started at -12, and then we rose, which would be plus 12 degrees, and it would be 0 degrees. The afternoon temp is 0. B tells us to rewrite subtraction as the additive inverse for the following problems and find the sum. The rule of subtraction, which we've done and we know about it. So first we're going to rewrite it, 2 plus -2, and the answer is 0. -4, that becomes a plus. My -4 then becomes +4, which equals 0. The difference between 5 and 5. So first of all, difference means subtract 5 and 5. Then we need to use that rule of subtraction. So that turns into 5 plus -5. And we know the answer to that is 0. Works the same with variables, g plus -g. And if I have a g and I take away a g, I still have 0. It doesn't matter what that g represents. If I have 1 and I take away 1, it's going to be 0. So what pattern do you notice? The pattern that I notice is the sum of a number and its additive inverse is 0. That's what we did on all 4 of these questions before. That number and the opposite, I got 0. Let's move on to the next ones. What's 16 plus 0? Yep, that's easy, 16. What's 0 minus 7? Well, remember, we do the rule of subtraction, so that becomes 0 plus -7, and my answer is -7. -4 plus 0 is -4, and 0 plus d still gives me d. So what do we notice in these 4? The sum of any number and 0 equal So the sum of any number and 0 is equal to the value of the quantity that we had before. So your younger sibling runs into you, excitingly exclaims, "I'm thinking of a number." And if you add it to a number 2 10 times, that's 2 plus her number, plus her number, plus her number, and so on, the answer is 2. What's my number? You almost immediately answer 0, but are you sure? Can you find a different number other than 0 that has that same property? If not, justify your answer. No, there is no other answer. If I'm at 2 on the number line, so say I'm at 2 on the number line, here's my number line, there's 2, and I'm going to move, if I'm going to add a number, I'm going to move something. Which brings me to a very important keynote here that I want you to write here, that 0 is the only number that when added with another number, the result is that other number. So that's exactly what we're talking about here. If I have 2, the only number that I can add it with and stay 2 is 0. So in these first 4, remember we had the additive inverse. And the additive inverse always equals 0. Is 2 numbers that add to 0. Sometimes we call that the opposite. Sometimes we call that the additive inverse. Let's move on to example 1. It says to write the sum and then write equivalent expressions by collecting like terms and removing parentheses. So the first thing that we need to do is let's write it out in a number sentence. Let's get rid of that word and we know the word and means plus. So 2x and negative 2 plus 3. I'm writing negative 2x plus 3 in parentheses because they are together in the sentence. So now, let's use the associative property and let's collect like terms. So I'm going to put these two x's together. So I'm going to put these two x's together. So what did I do? Move this up right here, bring back to where I am. This is not behaving for me, my apologies. This was the associative property. And then I'm going to collect my like terms. Oop, and I see I spelled associated wrong. There we go. Associated property and collect my like terms. So I am going to put together, oops, my apologies. Let's go back to where I was. I'm going to put together my 2 and my 2x. They are additive inverses, so I get 0 plus 3. And then I add any number with 0, and I get 3. So the next step after that, come on, this is not behaving. So the next step would have been additive inverse. Oop. additive inverse, and that's putting that 2x and the negative 2x together. And then the last step was the additive identity property of 0. Now we call it the additive identity property of 0 because, like we said before, 0 is the only number that when I add it to another number, that result is a 0. So we like to call that the additive identity property of 0. So let's do it one more time. The opposite of 2x the opposite 2x minus 7 and the opposite of negative 2. So first we need to rewrite that 2x minus 7 and the opposite of 2x. And remember, to write the opposite, we multiply it by negative 1. First thing to do, let's use the rule of subtraction. So first thing, let me go back to that. First thing that we're going to do is the rule of subtraction. So the first thing is the rule of subtraction. Next, we are going to do commutative and associated property, which we would call any order, any grouping. Next, we are going to then know that the additive identity property of 0. So let's go over that again. So the rule of subtraction makes me rewrite it as 2x plus negative 7 plus negative 1 times 2. And now we're going to do the opposite of that. Let's do our multiplication first, and we know that equals negative 2. And then since we have all plus signs, we can do any order, any grouping. We can rearrange that anytime we want. So I'm going to rearrange that 2x plus negative 2x because that became negative 2x. And then I'm going to add my negative 7. I know those two equal 0. 0 plus negative 7. And my additive identity, I add anything to 0, I'm going to get that number. So my answer is negative 7. Let's do it one more time, and then I'm going to let you try it by yourself. Next, we are going to do the opposite of 5x minus 1 and 5x. So first, we're going to write that out. The opposite, I'm going to multiply it by negative 1, 5x minus 1. And then which would be plus 5x. So the first thing that we're going to do is we are going to take the opposites by multiplying by negative 1. Then we're going to use the distributive property. Then we are going to use any order, any grouping. then additive inverse, and then additive identity. Okay, so let's talk about that again. So the first thing that we need to do is we need to multiply that -1. So we are going to find the opposite by multiplying it by -1. Then we need to distribute out that -1 to both of them. So that becomes -1 times 5x minus -1 times 1 plus 5x. Any order, any grouping. Oh, so I'm going to distribute it out, and that becomes -5x plus 1, because a negative times a negative equals a positive, plus 5x. Then I'm going to do any order, any grouping. So I'm going to put my two 5x's together. So I have -5x plus 5x plus 1. Additive inverse, those two 5 and -5 are additive inverse. So I have 0 plus 1. And then the identity property of 0, whatever plus 0 is still that same number. So my answer is 1. So I want you to try exercise 1. Answer all 5 of these the same exact way that we did before, using any order, any grouping. So remember, once they're all plus signs and you use the rule of subtraction, you can then rearrange them anything you want. You're going to put two together, that two numbers that are additive inverse, put them together to get 0, and then you're going to have 0 plus that number, and using the additive inverse, your number is 0. So this will be our first stop and check. Will be all 5 of these. Pause the video, complete these, raise your hand, and I will come and check them. Next, let's look at example 2. Example 2. Hopefully by looking at these, you can know the answer of all 5 of these. Three times 4 equals 12. 4 times 3 equals 12. My answer is 1. 4 over 1, that also equals 4 over 4, which equals 1. This one equals 1. That a negative times a negative equals a positive, so positive 1. A negative times a negative equals positive 30 over 30, which is 1. So what are these pairs of numbers called? The pair of 3 over 4 and 4 over 3. They are called reciprocals. They are called reciprocals. So when you flip it, it's called a reciprocal. Another term for that would be multiplicative inverse. So remember, inverse means to flip. We're flipping it when we multiply. Again, what happens to the sign in the multiplicative inverse? The sign stays the same. If we have -1/3, my multiplicative inverse is -3, because because a negative times a negative is a positive, and we are trying to get it to +1. So what's so special about this? Let me get this down. So the key point that I really want you to get is that 1 is the only number that when multiplied with another number, it results in that number again. So 1 is special because it's the only number that you can multiply and get that same number. So we're going to need to use this multiplicative inverse, use the reciprocal to help us get that number again. And this again is called the multiplicative identity property of 1. So we know how to get the opposite of that number is to multiply by -1. But if I don't want to change the number, I just multiply by 1. So let's do these next 2 questions real quick. Next 3 questions, and then we'll see, and then we'll let you try some questions just like this. So first we're going to use the multiplicative inverse of 1 over 5 and 2x minus 1/5. So first, the multiplicative inverse of 1/5 is 5th, and it's going to have the parentheses, so it would be 2x, and I keep my minus sign, 1/5. Now I'm going to use my distributed property, so I'm going to use my distributed property, and that's going to become 5 times 2x minus 5 times 1 over 5. And I know that 5 times 2x equals 10x minus 5 times 1/5 equals 1. Those are multiplicative inverse. Multiplicative inverse. I got those 2 are my multiplicative inverses, so my answer was 1. And I was able to simplify that to 10x minus 1. Next is asking for the multiplicative inverse of 2 and 2x plus 4. So multiplicative inverse of 2 is 1 over 2. That's going to be in parentheses. And then next is going to be 2x plus 4. So again, first I'm going to distribute. So that's going to be 1 over 2 times 2x plus 1 over 2 times 4. So 1/2 times 2 equals 1x plus 1/2 times 4 equals 2. And again, that was my multiplicative inverse because those 2 numbers left me with just 1x. So I can rewrite this as 1x plus 2, or I can just rewrite it as x plus 2. Because remember that that 1 is just assumed, and we do not need to write that 1 that is connected to the x. Let's do this last one, the multiplicative inverse of 1 over 3x plus 5 and 1 over 3. So again, to get the multiplicative inverse of this, we're just going to flip it. 3x plus 5 over 1. We flip it. And if I divide anything over by 1, I have that same thing. So I really don't need that. And 1/3, so times 1/3. So I'm then going to distribute out that 1/3 to both of them. So I'm going to distribute. So 3x times 1/3 plus 5 times 1/3. Multiplicative inverse, so multiplicative inverse of 3 and 1/3, I'm left with 1x plus 5 over 1 times 1 over 3 equals 5/3. And I know that my multiplicative inverse gave me that 1x. And I know if I'm multiplying anything times 1, I am left with that number. So I do not need that 1, and I can just leave it at x plus 5/3. Okay, let's move on to exercise 2. I want you to try all 3 of these and then raise your hand and I will check them and see if you did well. So all 3 of these will be stop and check number 2. Pause the video and then we will finish real quick. Okay, welcome back. I hope you did well on the next 3. Before we move on to the problem set, I have a few little notes that I really want to make you get. So today's question was, what is so special about 1 and 0? So we know that 0 plus anything equals that number. So 0 plus 4 equals 4. 8 plus 0 equals 8. So 0 does no change in addition. And then 1 times anything equals that number. So if I'm multiplying anything by 1, I'm just going to result in that thing that I multiplied by. So in the future, we're going to use these zeros and we're going to use these ones to help us manipulate these equations. So again, I'm going to go back to these important notes that we did before. Remember, 0 is and that number is the additive inverse of 0, and the sum of that number is equal to the value of that quantity. We'll talk about that more about that in the next couple of lessons. And then when you're multiplying, where did I go? Right here. When you're multiplying, it's going to result in that same number. A lot of times that 1 is assumed. So if we have 1x, we are multiplying 1 times x. So we really only just need to write x. So before we go, we need the problem set, and I want you to do all 4 of the problem sets. They are very easy. They're just like the questions from before. When you are done with that, you can raise your hand and I'll give you a final check for all the problem set questions. And then you will be done for today. Thank you.